So this is an exercise where we will do some engineering because we need to figure out the dimensions. So let's say that 0.6875 is diameter of the hole for the pen. Then we need to figure out what is the base feature here. The base feature is a cylinder. And then what we can do, we can make another revolved feature here, which we will subtract. It will be a revolve cut, and then array it 6 times around. And that's like those finger grips or whatever of the revolver barrel. And then we can make a one hole, and we can just array this hole 6 times, and we can decide how we want to do it. I like that it has also central holes so that we can place more pens. Okay, it's a very cool piece actually to make. So other dimensions are given to us, are free to choose. So you choose, so everybody will have slightly different. I highly recommend to stick with a standard series of numbers. First you decide, do you want to do it as an inch piece or as a metric piece? If you are going to do it as an inch dimension piece, then you go like a half inch, quarter inch, 1/8, 1/16, 1/32 for all of the features as a series of numbers. If you are doing it in millimeters, let's say it is a 60 millimeters, so you can go in an increment of the 1, 10, or 0.1, 0.01. So it's like in increments of tens. So not every order of magnitude we divide by a 10. So, okay, let's start making it. I'm going to make mine in inches, and I'm going to make approximate. There is no minimum or maximum dimension here that we have, but we kind of need to stay within the idea of this object. So I'm going to start a new piece, and it is in inches. I'm going to make a sketch on a front plane. I'm going first to make one vertical center line. No dimension necessary for a center line. Then I'm going to make a one rectangle. And then I'm going to make this rectangle to be, let's say that this is a 2.25 inches. And then diameter, you see that I choose the left edge line, then I choose my center line, pull on the other side to put the diameter. And then I'm going to make another rectangle from this point, from the upper right point of previous rectangle, up. And let's see how much, and let's say that we want this one. Again, left, we choose the left edge. We go to the central piece and we go on the other end. And let's see if we put it 2.0 inches. And let's see how it look like. Well, that kind of look like what we want. Maybe it's perfect. So we need also to make the heights. So we know that the total height, we should be around 2.5, let's say. And then we know that this one to be a proportional, maybe quarter inch, the base. Okay, so this can be the contour that I can use to create my pieces, and I can choose multiple contour because in this sketch I have a multiple contour to create like my base cylinder. Now, I'm going to go back on my sketch plane. I'm going to sketch on the front plane. And I'm going to sketch a center line which will be coincidental with the outside contour of my cylinder. And let's see how deep is this approximately. Maybe about, if this is a 2.5, maybe there is about what you will say like a 1/3 of the depth. So let's think about it. I'm going to place that holder by making the center point straight slot, which I will break and then redefine. So if I make a center point straight slot, something like this. Now I can make some dimensions. Let's say that this is a 1.0. That's maybe a too short. Maybe 1.25. And now how much deep? We don't want to get that much into the barrel itself. So maybe the radius of 0.5 is too big. Let's say a radius of 0.25. And that will be about right. Now, we will need to break this slot. I don't really care how high is this slot, but I will need to make like the central heavy line here. I will need to close it here, because that's the contour that I would like to actually, and pull out a center line. That's the contour that I would actually like to revolve. Just this contour here, and in order to make it to be closed, I will need to make this line to be coincidental with the arc. Now, when I do the revolve, I will just choose this contour, and I don't need to trim anything else. Let me show you. I will do the revolve cut, feature, revolved cut. I will choose axis of revolution, my axis, and then I will click on a select contour, and I will just choose this contour. And blind for 360 degree, and let's see what will happen. The resulting contour intersects the center line. Please reduce the thickness. So let's see why it is the case. So if I go back to my sketch, I will actually need to do a trimming. I was hoping that I may not need to do. Okay, I don't care that you destroy the... Okay. And now I will need to I can put actually this to be like to here, with this point and this point being coincident. And now what we have to specify is a one more dimension, and that's this one here for 0.25. And let's see what else we have there. And if this arc and this line is a tangent, then it is fully defined. Now let's see if and I will be sure that my center line are collinear. That way there is no possibilities for the intersection. So now if I go back to my features, and if I go for the first time, I will do the revolve cut, choose my center line. Now it's pick up. So the key was, although it was collinear, to introduce explicitly collinearity. Otherwise, there is that little, whatever, maybe 7th or 8th decimal, but it messed up formation of the feature. And then let's click OK. And here is kind of like my finger grab for that revolver, okay? For that revolver barrel. Now, what will be the next thing? To create circular pattern. So I will go under a linear pattern. I will click circular pattern. Direction will be my outside of the cylinder. I'm going to make a 6, and it will be an equal spacing over 360 degrees. And does it started looking like a revolver? Like a revolver barrel? Now, what we are going to do, we need to figure out my points here, and we say that it's pretty thick, so let's say we can put 0.6875 holes, 6 of them. So I'm going to sketch on the top. I'm going to put the center line from the middle to the top. And I'm going to place, for now, a circle, although I will use the whole wizard, and I will show you why. But I just want to have some visual about how big is this going to be. What is the 6875? That's a huge hole. So I need to figure out approximately where I can place this hole. Obviously, if I use this hole, I will not be able to put the central hole, and that's fine. So it will look kind of like the first one. Now, if I use I put it kind of where I like it. Now let's find the standard number. And the standard number actually of 0.5 will work perfectly. So half an inch diameter. Okay. Now, what I can do, I need to see how they will fit if I array them. I can array them in the sketch as a circular sketch pattern. And let's see if this will work. Number of them 6. What can you tell me? Will this work? Why? Because they will overlap each other. So then what are our options? Either to make it for a smaller pans, or what else we can do? Can we change this one to be a little bit bigger? Yes, we can. So sometimes we will just need to go back. Actually, if I show the annotation, feature dimensions, I can see from here some of the feature dimensions. Well, it actually is not visible, so I will go back to the sketch. That will be under Revolve 1. I will modify my base sketch and everything will expand. So instead of 2.25, how about if I put this to be a 2.75? And this one, okay, and this one to be a 2.5. Click OK. Now can I do the array? Let's check it before we do further. First, now we can move this up, maybe a 1. 1 is too much. 0.75. That will be actually a good position. And now if I linear circular sketch pattern, parameter is a point because we are in a sketch, number is a 6, and entities is my line and my circle. Now look what happened. Can they overlap? They are not overlapping. They are in a perfect position. And what else? We may be able even to fit a one more. And if I click on the new circle and this circle, let's say if I say equal, actually we do have a space to fit the central pen. So perfect. However, we are not going to do the extrude cuts because we are beyond that stage. So we are going to use these points for making the holes. So I will just choose everything in this sketch and click here that it is for construction. Okay. So I have sketch for construction only. Now what I will do, because we are professionals and we use the hole wizards for the holes, click on the hole wizard, and I will use another hole type, which we haven't used there, and that's the generic hole type, where we can specify dimension. Generic hole type is this one here. It's called legacy hole. And it will be a simple hole, and the diameter is going to be 0.6875. And the depth is not a true hole. Look, this is a 2.5. How about depth of a 2 inches? Will be, I believe, more than enough. So we will choose true hole to a blind, and we will put the depth of a 2 inch. And now, if I click on a tab of the position and go on this sketch, I can position this on every single predefined point. Or I can make one and array. Either way is equally successful operation. This was actually, and guess what? We have completed our piece. Well, we have not yet. What else we need to do? The hole wizard that we choose was not correct because what else we want to know here? That end condition is blind, but however, we want to see that this hole is actually bored. Let's see. how can we see? Change it to a bored hole. Simple drilled hole, not bored, but simple drilled. And the simple drilled is here, and the depth is a 2 inch, as we say. And if we use it as a simple drilled hole, then it has, you see, the point of the... However, something has happened here with the chain, with the dimension. Yeah, I did not want this. Diameter is 0.6875. Click OK. And you can see now it ends up with a what? With a drill angle, with a 118 degrees drill angle. And the last thing that we want to do, there is some fillet here and some chamfer there, so that we don't get cut. So if we go with a fillet and maybe a 1/8 of the inch fillet, and I click here, and I also click here. No, not the face, but the edge. Let's see. Let's actually start one by one. Actually, that's more than enough. So just the one fillet will be fine, unless we want to make 16. And we want to make some small chamfer on maybe a 1 millimeter and 40, like a chamfer, maybe a 132 at 45. And that chamfer we can actually put everywhere so that we don't get cut when we grab this holder, this pen holder. Let's see what's happening here. Let's do it again. Chamfer, under the fillet. We go for the chamfer. Actually, we just, if I click on the face, let's see if that will work. That will work. Okay, so I can chamfer this face, and that will kind of complete everything. And I can chamfer individual faces here if I want to. Let's see. That will not work because of the intersection, but however, if I chamfer these two, that will work, that work, that work, that edge work, and that edge work. And this will complete our pen holder. I don't know, somebody may buy it on Etsy or something like that. So again, we have created here, the example was that we create something just out of the photo and out of the basic dimensional requirements, kind of, you know, like something that kind of like the boss at the company will give you a sketch and say, hey, make me a piece like this. Okay, let's try to make this piece now, you know, and everybody will have slightly different piece, obviously. Like, so you choose...
Step by step, especially going from the center line to making
Sure, here it is, it's recorded, so